All right, so we are back in Houdini. Now, let me bring our alembic inside. Let me put down a geometry node. And maybe I'll just name it, just to be clean. Now, I will read an alembic file. So, alembic. And we have two of these, one for the character itself. So, let me find that. It should be in cache. Alembic Croc ABC. So I have the model. Now I want the scales. Well, let me delete this off. This will be the main body. And this is scales. I'll bring that in. Now, the first thing is setting up the scale, the size of the character, I mean. So for that, I need an RBscalegen node. So I'll put down an RBscalegen node, and you can connect it to the in-mesh. Now before that, make sure you blast off everything else from the body. We only need just the area where we need to generate scales. So what I will do is I will first convert the whole thing, because right now it's an alembic format. You need to convert it so that you can access all its vertex and all the data associated with the alembic. So now you have UVs, you can see. All right, so what I will do is I will blast off body, or what we can do is we will click on the node itself, or just blast it off. All right. So, and one of the prerequisite of working in RBscalegen is that you need to maintain point order. The reason being, we are using some paint tools in generating the scales. So it's always better to finalize your topology, and otherwise, if you change the topology, it will mess up all the paint data that you have done. So it's always ideal that you finalize your topology and then start doing generating scales. All right, so in here, I'm going to do is going for the body shape and delete not selected. So I have isolated just the body. Cool. Now what I'm going to do is I want to set up the scale properly. So if you click on RBscalegen, don't worry about all these. There's an option called scale guide. So if you click on it, it will show you what is the size we should be having for the crocodile. So this will automatically set up a scale for you. Now, this is not automatically set. You have to put down a transform node. Maybe I will add it here before the blast node. Okay, so this is the scale right now, what we have. And if you template this RBscalegen, you can see this is the scale that we need. So you can scale it up. You can scale it up maybe in a uniform fashion. Position is not important, scale is. So roughly scale it up so that it roughly fits the template. So I think a 1.5 or maybe 1.6. Yeah, that seems to be correct. All right, so now you can come out of scale guide and then you can connect it over here. Cool. So this is the correct scale that we have to manage. Also the direction. So if you see here in the scale guide, the direction of the pig is the direction that you need your body to be facing. The pig head facing, so that should be maintained. In this case, this is correctly pointing in the Z axis. So this is correct. So I will connect it back, and now that is matching. Now, if you go to mesh resolution. If I click on scale RBscalegen and come out of scale guide, it will automatically generate all these scales. Now it is not filled up, and the main reason for being is not enough resolution. So there's a section called mesh resolution under global controls. There you can increase resolution, but be careful about this, because more the resolution, slower it gets. So maybe I'll go for a 2, because it's a huge big character. So subdivision means it will subdivide quite a lot. So be careful about adding resolution. Add one by one and see how it's affecting your machine. Okay, I think this mesh resolution 2 is fine. It seems fine and fast enough. And one more thing is that you will have to paint on this mesh. So it's vertex paint. So basically that means that resolution should be enough for to paint properly. So what you can do is you can test out tiles. So this is how it is split up. Now if you click on tiles paint, you can see this is how your resolution looks like. Maybe you would need one more so that you have more to paint with. So what I will do is I will convert this to 3 so that I have more vertex. Okay, so now you have better resolution to paint on. So once you are happy with this, you can go with this, and this seems to be perfect for this character. Cool. So if I try scale slow again, it will be slightly slow, but still it's fast enough, I guess. All right. Now once we are happy with this, it's a good time to save the scene. So I will save this 2026 Croc. Let's save it here. Okay, so that's good. Now, as you can see here, this character doesn't have any sculpt details because I didn't do any sort of sculpting on this. Now in production, we generally will have some sort of details on top of it, more muscular structure, all that. You can have that, but when you export from ZBrush, take the lowest resolution, which is manageable, and bring that in here to generate scales. And you can also have a version of high resolution in here to project all these scales onto that. So for that, you have a section here, projection mesh. So in case you have a high resolution mesh, you can always bring that in and connect it here so that the scales can project it and fit well onto the high resolution mesh. So there is an option for that, but in this case we are not going to do that. We are just going to use this and generate scales. Cool. So now that we have done that, what we can do is we can take a look at the reference and see that there are different types of scales on this crocodile. Now most of these, all these you see, can be easily generated without painting itself. And some of these are different types of scales that we already have built. We just have to add draw ID curves for these. So you can see there are different types of scales. So I haven't planned about this bottom scales. Maybe it would be a situation where we have to scatter geometry, more like kind of rectangular geometry, scatter it and convert that to scales. So we will get to all that. For now, we will find the correct size of the tiles. Now, what we have generated looks all right. So if you go to tiles, the scales, tile size might be okay in this situation. We can always change it. So let's say if you want bigger sized tiles here, then you can go to the density paint. So let's say I want bigger tiles in here. what I can do is I can go to density paint. I will switch off this. Okay. And then you can switch on um, the manipulator handle, and you can start painting. So in the paint section, so once you have density paint option on, you will have a tab for paint. You can go for symmetry. I believe so this should be -1 direction, so that should be correct. Now what I'm going to do is I'm going to increase the radius, pick a value from here. So this is automatically generated, these density values, but you can override that. So in the FG float, it's 1.9. Maybe I'll take it to 3 so that we have bigger scales here. All right, so what I'll do is I will have bigger scales over here, top. And if you look in wireframe mode, you can see this is in the under the hood. This remesh geometry, which takes values from the painted geometry, which is the base geometry, and then convert it. So when you rotate around, it actually makes the calculation and adjusts the triangles. Even in here, I will like to have these bigger triangles. Okay, maybe you need to smooth it out a bit. So Control Shift radius, increase the radius, and if you shift is the basic standard Houdini brush operations. So you have bigger triangles here, and yeah, I think this seems to be all right. I was also add a similar kind of thing underneath. Maybe in here, I think should be good. And smooth. Okay, so that seems to be all right. So I'm calling this decent enough. Maybe somewhere here I can go to 0.2, and in here we have bigger, and smooth it out. And similarly here. So these sections will have bigger tiles, while these areas have smaller. Always keep reference. I'm always referring to these to get a rough idea of how the scales look like. Maybe all these sections we will have to paint manually, the scales itself. It doesn't look like proper scales like these. Oh, actually you can see some close-ups here. Cool. So this seems to be a good reference. Okay, now what I will do is I will do a partition so that I can manage it a little better. So how we go about it is very simple. Create a group. Good. And for this, I want to focus on face. So what I will do is I will create a group called face, or yeah, face should be good. Now I will make a selection based on UVs. So it's a good thing that I have. And we forgot about one thing. We don't want the um, whole body, and I shouldn't have painted the density because I should have deleted off all the geometry that we don't need, especially in the mouth, in the eye, all that. So that's a mistake from my part. So we'll have to do this again, the painting density. So that is an important thing. So first, already have a blast node for isolating the body. What I will do is I'll put another blast node and delete of unwanted areas. You can also create a group and then do it. But what I will go is I will go straight and using UV this time, I will remove those that are not needed. So in this case, this, okay. Enter, then this shift select. Okay, so that is done. Maybe, actually, you know what? Let's leave it there. It should be fine, I guess. Okay, so we will go with this. Now, since the pane node and all the nodes, the draw nodes inside the ScaleGen is reliant on point order. If we change blast or blast off something after painting, you will lose all that. You certainly can do a reprojection. I believe it's inside recache rocks. You can always do that. But I would say that uh, make this or get this right first and then start painting. Cool, I guess this should work. Okay, now what I will do is I will make some groups for the partition. So if I make this a face group, I will write the node name and the group name same, face, and let's do it. So for the face, I'm going for this area, enter. So this will be face. Now what I want, I will just copy that. What I want is maybe legs separate. I can take both legs, back and front. So I just do that. Okay, so that will be legs. Legs, that's legs group. Now I will do the same for body and tail. So this will be body. What I'm going to do is I will come out of uh, connected geometry mode and then use control A to deselect these, and yeah, so now I have body, enter that. Then after that, do the same thing for tail. So what I can do is I can do a control, oh actually, shit, I think. Select. Yep. So tail. So I have tail, I have body, legs separate, and face separate. Cool. So this is what we want. Now you can connect it back to RBscalegen. Now obviously the density is all messed up, as you can see. So if you want, in the density mode, you can do a recache rocks, which might work. Okay, that can work. So if I try, oh, okay, actually I got it back. So I have it, the density painted. It's not a good idea to do it, but you know. All right. So with density pane restored, what we can do is go to the partition section of it. So in the global controls, if you go up, there's a partition folder. Now expand that. And for now, we don't have any sort of partition. So if you click on one, you can add. So in here, you will get a list of all the group coming into the node, RBscalegen node. So let's go for face. So we'll focus on face. Now you can add more. Let's say I will add body and legs and one more. Let's add tail. You can do this at any time. Now I will, so you have this active button. So if I click on active, you will get this section, the head section. And you can come out of all the pane nodes just to see. So in here, in the default mode, you have this drop down to debug. So in this case, let's go for tiles. So this will show you the tiles, how it is generated, which already looks good. Now, if you can look into gen scales, which is the higher final scales that you have generated. In this case, we haven't generated anything, so there is nothing in there. You can check the vector. That means the direction of scales. So this can be edited by drawing over using a curves so that you can define the direction of the curves of the scales itself. Now there is template scales which give you a way to edit the base default scales. Now scale slow, which shows you how the base scales look on the character. This gives a cheap way of seeing the scales without generating high resolution scales. Then you have scatter points, which define how the points are scattered on the surface. So this defines the scale. So more the distance between points, bigger the scales. Smaller the distance, smaller the scales. That is the idea. There is a section here in points. So let's say the tool generated points, you are not happy with it and you want extreme control over it. For instance, if you're working on a snake, you will want precise points placements because of the honeycomb structure. So if that is the case, you can have your own custom mesh build or points added manually, and you can connect it in this green button, in this green input. So that is an option. Now in this case, we don't need that. And if I go back to tiles paint, this is a cheap way of seeing how the tiles are split up. You can also check this in tiles, but this is much more faster. Now blend spread. Now we don't have a blend spread yet. This is mainly comes handy when you have hand painted scales and you want to blend it with the rest of the scales. So right now it's not available. Anyways, so let's take a look at tiles. Cool. For now, I'm not doing anything. I'm going to generate high scales in this using the symbol scales that we have here. Okay, we are not changing anything, just straight out of the tool we are going to generate a higher resolution or scales. So let's come here and there's a section to generate mesh. All right, and this is the name. If you want to change the name, you can always change it, but I will tend to give the hip name. That is the name of the scene that you have here. That is Croc v1, and that should generate a mesh for you. So what I'm going to do is I'm going to generate a mesh. First I will save it, Okay, I haven't done anything, so we'll just see how that comes out. All right, so I'll give it a generate mesh, and you can see it's cooking over here. It takes a bit of time depending on the resolution of your mesh. Cool.